Hello 2412 students. This is Basics of Trig for Calculus students, Part 2. Some essential facts about Euclidean geometry that you absolutely need. Okay. One of them is that the sum of the angles in any triangle is pi, or 180 degrees. And therefore, when we look at an equilateral, which means all equal sides triangle, the angles from geometry, we know the angles have to be the same, and if they're all alpha, then 3 times alpha is equal to 180, or alpha is equal to 60 degrees. Okay, so that gets called a 60-60-60 triangle. If we're just going to call this length of the outside 1 unit, then we have 60-degree angles on all sides and 1 on all sides, right? Now, if we take half of that, right, if we, from one of the vertices, drop a perpendicular, what happens to the lengths of the sides now? If I split this in, remember that it was dropping a perpendicular on an equilateral triangle that's going to be symmetric either side, and therefore, what's the length of this bottom of that triangle now? Well, that's clearly 1/2, right? So now, and we dropped the perpendicular, so we have a right angle here, and of a right triangle with sides of length 1, 1/2, and let's call this altitude h. And pull out another fact of Euclidean geometry. We need the Pythagorean theorem, that if you have any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides, which get called legs. And it doesn't matter where you put A or B there, but usually people do something like that. So the Pythagorean theorem in general is that this short leg squared plus that longer leg squared length we're talking is equal to the square of the hypotenuse length. So back to this example over here, we clearly have that h squared plus 1/2 squared has to be equal to 1. And now you have a quadratic equation to solve, which is why you have college algebra before you have trigonometry, right? And what happens there? So you should stop the video and solve for h and come back. When you come back, you should see something like this on your paper. H squared plus 1/4 is equal to 1, so h squared, if you subtract 1/4 from both sides, is equal to 3/4. And what does that give you? Using the square root principle, also from your college algebra class, you should get that h is equal to plus or minus the square root of 3 over the square root of 4, which reduces to a 2. And that's the fastest way to rationalize that one. That would be plus or minus from the algebraic point of view, but h is an altitude, right? So this triangle has sides 1, 1/2, and the positive square root of 3 over 2 here. This triangle, what does it get called? Half of that equilateral triangle, conceived in this way, still had alpha in this corner, so that was still 60 degrees there. That's a 60-degree angle there. And opposite would be its complement, 30 degrees. So that's a 30-60-90 in these proportions. If the hypotenuse is 1, the short leg is half of it. So to go from here to there, let me show you a little trick that's really handy. To go from the hypotenuse to the short leg, you just divide by 2, right? To go from the short leg to the longer leg, notice that we're just multiplying by the square root of 3. 1/2 multiplied by the square root of 3 gives you square root of 3 over 2. This comes in handy later. All right, so now we have a 60-60 triangle, a 30-60-90 triangle. If the hypotenuse is 1 in the 30-60-90, we know it's the lengths of its other legs. So the long or short of it is that using the Pythagorean theorem, we end up getting that the 30, 60, 90 triangle always has these proportions. If one is on the hypotenuse, the short leg is a half of that, and the long leg is a square root of 3 over 2. Okay, so you need to have that always at the ready. Here's another one. If we started with a square, all sides are the same length s, and split that right down the diagonal, okay, we would get a triangle with, if we split that 90 degree angle into half, so we get a 45 triangle, right? And using the Pythagorean theorem again, we're going to get s squared plus s squared is equal to 1, or 2s squared is equal to 1, or s squared is equal to a half. You stop the video and do the rest of the algebra here. Coming back, you should have been using the square root principle again. We end up getting s is equal to plus or minus the square root of a half. But here, because in this application s is the length, we've got to have s greater than or equal to 0. So that makes s equal to the square root of a half, which is equal to the square root of 1 over the square root of 2. Square root of 1 is just a 1, so that's 1 over the square root of 2. Can't have radicals in the denominator. We rationalize in this way. Do you have to rationalize your answers? Yes, if you want full credit for them. And we end up getting that the length of the two legs in a 45, 45, 90 triangle are square root of 2 over 2, each one of them. Okay. All right, so using those facts about those special angles, 30, 60, 90, 45, also known as 30 was what in radians? If that was a pi, if 3a was equal to, alpha was equal to pi, then alpha would be equal to pi over 3, right? So if a 60 degree angle is pi over 3, what's half of that? So that would make this 30 degree angle equal to pi over 6. 60 is equal to the pi over 3. How about these guys? Notice we had a right angle, also known as pi over 2. This is a right angle. We split it in half. 1/2 of that is equal to pi over 4. So for angles like pi over 4 or pi over 6 or pi over 3, we now know what the resulting right triangles, what their lengths of their sides are. This is the stuff you need from geometry to be able to now go back into the trigonometry definition of cosine and sine, which is in the third video.